Good morning, guys. As you can see, I'm all set up for our lab, and today our lab is going to be um, creating an alkene from an alcohol. We're going to be starting with cyclohexanol, which is in the opaque bottle in the water. Cyclohexanol is a solid at some cooler temperatures, and it's the Arctic tundra in here, so I have to heat it up so that it's a liquid. We also have some concentrated phosphoric acid. Those two mix together in the presence of heat, which is the water bath, which I will be setting up in a moment. On the left here, you can see there's a beaker of water and an immersion heater. But in the presence of heat, they undergo a dehydration reaction, which means the alcohol more or less attacks, the acid more or less attacks the alcohol, removes it, and a double bond takes its place. Okay? So, I'm going to go ahead and set up my immersion heater first. I've already filled my beaker with water. I know it says to fill it with less water, but that doesn't work out so well, so I filled it with more water. Note that I put the immersion heater in the water before I plugged it in. If I did it the other way around, the immersion heater would short circuit and we wouldn't be able to use it anymore. Okay. In the second step of my procedure, I'm asked to put approximately 2 grams of cyclohexanol into one of my smaller reaction vials. Now, I'm actually going to be using a larger reaction vial here because I'd like to ensure that I produce enough of the alkene in order to do all of the tests to confirm its presence. And we'll be doing 3 tests. We'll be reacting it with bromine water, we'll be reacting it with potassium permanganate, and we'll also be checking for its boiling point. So I'm going to take this, which has now been liquefied, yay. Tearing the mass here. I'm going to try to add about 4 grams. I think I can double the amount in the larger vial. TBD. It's very viscous. See if I can get some more in this time. Well, I'm only at a half a gram and I have to get to 4. You can see that my water has come to a boil. These immersion heaters do quick work. Halfway. almost at 3 grams. And I want to get to 4. Almost. Three 3.97, 3.9. All right, now I'm going to swap out for concentrated phosphoric acid. I'm going to use a serological pipette and a pipetter. Instructions say to add 1.5 mils, but again, I'm going to add twice as much. I have gloves on because I've had bad experiences with acid in the past. Note that this is corrosive to body tissue. So let's see here. I need to add 3 mils. Did it. That aside. Most important thing I can do is seal the acid now because I don't want to knock it over. In the next step, I'm going to take my cap and my reaction vial and I'm going to seal it tightly. It says to shake it vigorously. Still looking, they're not really totally mixed yet. You can, I don't know if you can clearly see, but I can, but they are different densities. And I want to make sure that they're clearly mixed. Okay. And I think this looks pretty good at this point in time. I can't even tell if it's in the camera, so I apologize. But now what I need to do is attach a copper handle, and the purpose of this is just so that I can fish this guy out at the end of the 20-minute incubation period. So I'm just gonna, ouch, this is not exactly easy, but I make a little hook like that. Oh, kind of want to make sure that there we go. I'm going to hook it over the side and let it sit. Okay. I'll set my timer for 20 minutes. I'll see you guys shortly. Alrighty guys, I'm back. It's been 20 minutes. I've taken my vial out of the boiling water bath and I've let it set on the desktop to cool. And my next step, what I'm going to be doing is filling a test tube with 8 to 10 mils of my 10% sodium carbonate solution. So to make a 10% sodium carbonate solution, you just take 10 grams in 100 mils. Now I'm going to use more than what they ask because I made more than what we were supposed to. So I'm going to add twice as much. Okay. And I am going to take a look at this. I've been letting this cool for quite some time now, but I think it's going to be okay. I'll mix it one more time. Take off the copper handle. And then I'm going to carefully open the vial because the contents might be pressurized. They're not. Okay. Now what I'm going to do is slowly pour this mixture into the test tube. We have an excess of phosphoric acid here, and that phosphoric acid is going to be neutralized, as you can see. By the sodium carbonate. They want me to gently mix this until the bubbling stops. Probably use a longer stirring rod here. Okay. I don't know if you can tell, but this is the excess phosphoric acid at the bottom that I'm trying to neutralize. It's more dense. You can literally see it, and I'm going to keep stirring until the bubbles stop. While I'm stirring this, I'm going to go get a test tube rack so that you guys can see what I'm doing next. Side. Next what I'm going to be doing is transferring the organic layer to another test tube. And once I get it to the other test tube, then what I'm going to be doing is washing it. my camera here so that you can really see. Okay. All right, so if I hold this up, you can see that there's an upper organic layer, and I'm going to work on transferring that into my empty test tube. I'm going to be taking it from the top and adding it. Up a little. Took a little bit of the wrong layer. You can tell because it separates in the pipette. Okay, and that's as good as it's going to get. And the next step, what I'm going to be doing is washing it with water. Okay. I'm going to take this over here. I'm going to grab my deionized water. Invert it gently. I'll let it settle. And in the meantime, I'm going to empty this water. And I'm going to use this beaker as a waste beaker. So now in this step, what I'm going to try to do is remove the water, which is going to be interesting. I don't even know if I'm on camera here with this. I'm trying not to take the organic product here. Although It's really difficult to do. This is good, because I'm going to get here. They want me to do this one more time. They want me to remove as much water as possible. I mean, so we can already tell it's not exactly easy. So I'm going to invert this. 1, 2. Try to let it settle. Separate it a little better this time. So obviously I'm not necessarily worried about recovery or efficiency here. I tried to make twice as much simply because with twice as much I knew I would have enough to do all my tests. But again, this isn't like an efficiency thing. So if I lose some of the organic product in this transfer of water, or removal of water I should say, I'm not really worried about it. Almost all the water is gone. Let's see what we got here. Just a little bit left at the bottom. I think we're good. And just see if there's anything left on the top. I don't think so. All right, there we have it. Now it's time for our tests. Alrighty guys, I'm back to do my 2 out of 3 tests. The 2 out of 3 tests are going to be reacting with bromine, that's the orange solution, and then reacting with acidified potassium permanganate. Finally, I'll do a boiling point test. The boiling point of our product is supposed to be around 83 degrees Celsius. So first, I'm going to add drops. It says 4 to 5, but I'm going to do 10. I want to make sure I have more than enough to react. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It says to add a few drops of bromine water. I can add 1 to start. And then if you'd like, I can add another, but I'll start with 1. Maybe I'll do 2 for fun. And then it's going to ask me to mix it. So I think the best is going to be to use this pipetter. And I will go up and down. And you can see that this telltale color, which was orange, is slowly fading. Okay. And if you want, I can do it again. Alright, so my cyclohexene reacted with the bromine. Bromine added across the double bond. Maybe I'll try another 2 drops. I mean, obviously, it's going to continue to react with bromine until there's not enough cyclohexanol left in the dish to react. But we'll see if this works again. And again, you can see that the color has disappeared. Okay, so it's a positive test. Okay. So now I'm going to add drops again. Oh, I think I already did 10 drops here, didn't I? I probably did. Oh well. How quickly I forget. Okay. And now what I need to do is add a drop of concentrated sulfuric acid, not my friend. To solidify it. When I said solidify, I really actually meant to say acidify. I'm tired today. Here we go. And now I'm going to add my potassium permanganate solution. Okay. I'll add a drop. You can see how deep this purple color is. I can even add another drop over here so that you guys can compare the two. And here I go with my mixing. You can already see that it is changing. It's going from purple to brown. And that's just a change in the oxidation state. All right. Okay. Okay. I think we've seen enough to show that it's changed its color from purple to brown. Okay. And next, what we'll do is our boiling point test. Okay guys, I'm back with my boiling chamber here. I've heated the water to above its boiling point, which was 83. And now it's slowly coming back down. We're at 82 and it has stopped. Okay. These tests are not always the most accurate because it takes some time for the thermometer to equilibrate. It also depends on how much you're stirring and how evenly the temperature is distributed throughout the water. So we got 82. It's very close to 83, and I'm fairly confident that across those 3 tests, we were able to successfully dehydrate cyclohexanol to create cyclohexene.